Okay, this is for a voice check. Are you getting my audio clearly?
Yes, sir.
Okay, so I'll just log out and he'll log in now. Okay.
Okay, sir.
Okay, right.
Yes, sir. We are getting you.
Okay, all right. Fine.
This call is now being recorded.
Good afternoon, sir. I guess you are muted, sir.
Now am I audible?
Yes, sir. You are
Yes, sir.
completely audible.
Audio is clear, huh? Yes. The PPT is visible?
Yes, sir.
Yeah. 1 minute. Just 1 minute. Now it is in full screen. Shall I start?
Uh, Sir, just give us a few minutes.
Okay, okay.
Ahuna, please take over.
Good afternoon to all. It is my great pleasure to welcome you to the final afternoon of SUSET 2024. As we gather for the closing session of this remarkable FDP program, I am filled with immense pride and gratitude to the journey we have undertaken together over the past few days. First, let me extend a warm welcome to our esteemed speaker for this afternoon, Dr. Shubhomay Basu. Dr. Basu, your expertise and contributions to the field have been an inspiring to many, and we are honored to have you with us today. We eagerly look forward to your presentations and the insights you will share. To our participants, your enthusiasm and active engagement have been the heart of the soul of this APP program. Your curiosity, questions, and contributions have enriched our session and fostered a dynamic and vibrant learning environment. I encourage you to continue participating actively in today's discussion and make the most of this final opportunity to learn and grow together. As we reflect on the past few days, we can take pride in the knowledge shared, the connections made, and the inspiration gained. SUSET 2024 has truly been a platform for innovations, collaborations, and professional growth. Today, as we close this chapter, Let us carry forward these lessons learned and the relationship built into our future endeavors. Dr. Bashu, we are eagerly anticipating your sessions, and I am confident that your insights will leave a lasting impact on all of us here. Once again, welcome to the final afternoon of SUSET 2024. Let us make the concluding session a memorable and impactful one. It is my great pleasure to welcome you all to this special session of SUSET 2024. Today, we have the honor of hosting a highly accomplished and esteemed speaker, Dr. Shubhamay Basu. Dr. Basu was born and completed his schooling in Durgapur, West Bengal. He pursued his higher education with a keen interest in applied physics and microelectronics, earning his MSc degree from Sikkim Manipal University at Tadau in 2002. He further specialized in microwave engineering, obtaining his MTech degree from the University of Bardhaman in 2004. Dr. Basu began his professional journey with a brief but impact stint as a lecturer at RCC IIT Beleghata in 2008. He embarked on a significant career at ISRO, where he has made remarkable contributions in the radar divisions. His work, particularly in tracking radar at the Satish Dhawan Space Center in Sriharikota, has been instrumental in advancing the radar technology. Since 2017, Dr. Basu has been working at ISTRAC Bangalore, focusing on the design and development of various ground-based atmospheric radars and advanced technology development projects. His areas of interest include the high-power microwave amplifiers, MMIC, planar antennas, radar signal processing, and unknown frequency detections. Dr. Bashu's expertise and innovative works have significantly contributed to the field and have established him as a leading figure in radar technology development. We are truly privileged to have Dr. Bashu with us today. His vast knowledge, experiences, and dedication to his field was inspiring, and we are eager to learn from his insights. Dr. Bashu, we are looking forward to your presentation and the valuable perspectives you will bring to your session. Your work exemplifies the spirit of innovations and excellence that SUSET 2024 strive to promote. Please join me in giving a warm welcome to Dr. Shubhamay Basu. Sir, this session is all yours. Please join.
Thank you, Mrs. Ahona Guchait. And I came to know this is a very nice session is going on for faculty development program. Maybe is it from QIP scheme?
No, sir.
Oh, is it? It is from Haldia Institute of Technology. They are arranging this. I am grateful to all of you for calling me and attending for this session. And what morning also I talked with Mr. Chakraborty. He told me that this session is arranged for faculties development program. So when I started this point, I would like to know how many are present here. At present, I am seeing 35 contributors in the scheme.
Sir, in GMeet, there is a 30 to 35 participant. We are streaming in YouTube also. There is also many participants.
Okay. So what we'll do, I have made this total presentation. I'll go forward. Anytime you can stop me. There is no problem. I'll answer all the questions. And this is particularly designed specifically for faculties. So there is no question of basic theories. What I want to share you that it will be system based, not subsystem also, system level, how radar technology in the modern life it is working. As of now, with my experience, where I worked or I have studied some information, that area, not all the things. So whatever is book is there, all things I am not going to cover. Which I have worked and some of the areas known, that only I'll cover. Okay. So shall I start now?
Yes, sir.
So please, you can interrupt me anytime. So since I am in PPT mode, I will not be able to see anybody is raising hand or anything. So please interrupt me and ask me questions. As first I am starting, this is the first slide. Now you can see that your one circle is there and something, one red spot is there at this point, and some one line is rotating. In the Hollywood movies, so many places we have seen this one. This is very common. Can anybody tell what is this?
Something detected in radar.
Yeah, correct. What is the, means is this circle called, anybody? It should be interactive. It is detection. Perfect. It's called PPI scope. Scope is a different type of oscilloscope we are seeing. This is one type of scope where in this radial range, anything is, any target is there, it can be tracked. Like a red color, it is indicating. So it's defined as a target. It should be noted for red colors. There may be definition from different colors according to strategy of that radar. Anyway, I'll go through. Next is my picture, and backside something you are able to see. Can anyone tell what is this?
It's a satellite.
Yeah, no,
No,
sir.
it's an antenna.
Yeah, correct. It is a very big giant antenna. It is situated near to Bangalore from 20 kilometers away. And one name is there. Name of the place is Bayalalu. There we are having some big size antenna as for reception of signal. Anyway, I'll go down next. The types of radars for space applications. Actually, this we started with space application, but space application purpose also, space-based radar, ground-based radar, all are used. So on that way, I starting this one. So tracking radar, all of we know something it will track as per definition. Doppler weather radar, this is very famous for weather monitoring nowadays due to disasters, disaster monitoring system. All we are seeing Doppler weather radars in different places of the country, specifically on the coastline. In Calcutta, one Doppler weather radar is there, that is in Alipur, very close to High Court. That is very famous. Gammatronic, one company is there in Germany. It is very popular. They deployed that radar at that time. It is nowadays what we are deploying with Indian industry in different parts of the country. So Gammatronic is previous version, but it has worked very nicely. Next is cloud radar. There is a difference between Doppler weather radar and cloud radar. Doppler weather radar will show clouds are moving towards us at some velocity, and at the same time there are some different parameters are there for cyclone monitoring. I'll come one by one, some pictures I'll show you. And cloud radar is different way. It is inside the cloud how the composition is. So there is a basic difference between Doppler weather radar and cloud radar. Doppler weather radar in our country, there is a different definitions in throughout the world, but in our country, it is S band, 2.8 gigahertz nearby, then C band and X band nowadays is coming. The frequency more it is going high, the coverage range will come down. Next is cloud radar. Cloud radar still high in our country. Few are installed. One is Mahabaleshwar, that is nearby the Western Ghat, and one more, I'm not sure, Samir is going to install that one where. Anyway, one is there at present, I know, and one we are making, very soon it will come into picture, and another is 94 gigahertz. Right now it is not there, not operational, and so it's going in the higher frequency range. And last is surveillance radar. Surveillance is nothing but it is monitoring the coastal area. Anybody is coming towards the coastal line, it's one sort of security radar. Next is space-based radar. It's synthetic aperture radar. You, all of you might have heard who are in this radar domain working or studying. Synthetic aperture radar, recently it came into picture. Earlier these radars are put in satellite and it used to roam throughout the orbit. But nowadays some companies are coming with drone. They will take image on drone, but all synthetic radars are basically that will cover microwave frequency. There is a difference between optical and microwave. Optical means image, microwave means microwave energy that may be radio transmit and reception. Third is meteorological. That is like it is like Kalpana. You might have heard that type of satellite is having this type of radar to monitor this one. And another is CloudSat. I have mentioned here. CloudSat is it's a like again that cloud radar from space. So these type of radar can be kept from space via satellite as well as ground, and then both of the information will be amalgamated and final product will come. And next is military or strategic radar. There is a space situational radar. Nowadays, this is very relevant topic where what is happening nearby our uh, particularly area where escape velocity something is going out. So I'll come to this point. Early warning system. You might have heard this ballistic missile is nowadays war is going on in Israel area that they are using very frequently this one early warning. That will give some early warning means it will be once it is fired, it is detected, the other area people will be informed very quickly. Next is Iron Dome. This also is a very special product of Israel. They made this one. So counter attack. Once is early warning and immediately Iron Dome is it will be counter attack and fire out that ballistic missile. Okay, so this is the brief things I have whatever I have summarized, but still MIMO radar I have not taken into account. MIMO radar I have not worked, and this is beyond working. I should not tell anything here. That's why we came out. And next is another very nowadays radar we are hearing that is like a drone based signal processing. That is also very coming into picture. Anyway, shall I move ahead? Any questions?
No, sir. Please proceed.
Okay, next we are coming phased array radar. Now, these among these radars, what is phased array radar? Phased array radar, we don't need to give explanation. Some of the systems I have displayed here, I'll just show all of you. These all are taken from internet, all are available. From top is multi-object tracking radar. This is one of the prestigious radar of ISRO, where this is a phased array big size radar in L-band, and it's for tracking the objects. Next is right hand side, that one more radar we are seeing. It's basically yellow color, whatever we are seeing, this is called radome. So there are different technology of radome. One is spear, left hand side we can see this point. This is different way, it's a planar radome. This is made by ELTA. ELTA is an Israeli company which is having the largest market share for radar selling. So they made this one. It's the ELM series radar. They are having different types of radar. Even if you will be surprised to know that they normally classical radar, when we studied all the thing, it's like a single frequency radar. It will single frequency will be for scanning and tracking. There are two parts. One is something is to be detected, that is called scanning. There is a mechanism. Next is once it is detected, where it is moving, that is called tracking. So these two parts. So one part they will do with S band, one part they will do with VHF band. It's a very critical thing they have achieved. So they are in a very vast way. They have done R&D and they made it. So it's a big achievement for them. This is our MOTR system. We have given a small thing. Just you can see one image how the antennas are there above a structure and it can rotate and all these things. But this picture is I got from internet. I was surprised, but it is a original picture they got from some source. I don't know, but it looks like from down to top. That picture it is showing. Next is right hand side. We are seeing one radar. It is in US X-band radar installed on coastal, not coastal. It is on the sea, central sea, to monitor sea launch. You may be knowing that some of the launch vehicles, means rockets, are launched from the center point on sea somewhere, where they should for the purpose of trajectory optimization. So minimum fuel it can reach to top. So it will be taken on a ship. It will be transported to some distance and then it will be launched. For that purpose, this type of radar are installed. I am showing just a system. It's a maybe people are working for 8 to 10 years to develop this system. So one day nothing is possible. Just to give a glimpse how the systems are working throughout the world. For that purpose only this presentation. And at the same time, people should get some inspiration to work for some of the new areas. I'm going to next slide. Multi-object tracking radar. This was initially ISRO's first work for the phased array. What we started there for tracking radar part. Radar can be tracking, imaging, different purpose it can be used. This was the tracking radar. Here they mentioned 10 objects up to a maximum range of 1,000 kilometer object size 0.25 meters square. These was the initial things, the target for making a radar. Then 1.3 to 1.4 gigahertz, that was the frequency, and it can track different stages of launch vehicle. Launch vehicle means rockets and simultaneously during nominal and non-nominal missions. These are the very critical thing for people are working. Non-nominal means when nominal means when everything as per your plan is going on. Non-nominal means it is away from your plan and some unwanted thing happen. At that time, how to save people, mainly human life and properties. It can come. There is the instantaneous impact points. There, what is the meaning of this one? Actually, it can be explained that when the rocket body is falling on sea, it is planned that which area it will fall. A rocket will have a 3 to 4 stages, and each is having its own type of fuel. Some are solid, some are liquid. Suppose how rocket and satellite is linked. I am not going this very inside. Rocket is a like a scooter or vehicle which is moving on the road. Like that, similarly, it's moving on the air. And a scooter is moving on the road, rocket is moving on the air. And passenger is there on the scooter, like that passenger in a rocket is a satellite. So there may be one satellite, multiple satellite, depending on their mission planning. Some will go at some distance, another will go another trajectory, something up. So these are the thing all planned. Similarly, when the rocket body will fall, where it will hit in the ground, not I should not tell it's ground on coastal line sea. These points are denoted as IIP, instantaneous impact points. Currently used for space debris proximity analysis in powered and orbital phase during satellite launch, re-entry predictions of debris. Re-entry means you might have heard that some old satellite which is completed its total work and coming back to Earth because of no fuel. These are the called re-entry, or sometimes it is intentional. That is unintentional. It will come back after some time, but some of the things intentionally it will go out and immediately within one day it will come back. That is re-entry. So if you are, if that suppose some of the ballistic missiles it will go out of the our uh, some trajectory and it will comes back, then people will not follow for some time. They want to take the advantage of that. Third is the last point is TLE. TLE is two line element. Any satellite is there. It's how to define this address. That is called two line element. By that way, normally address is defined. So these are the things. It's a standard in the practices people are doing. For that purpose, we made this radar. So the thing is, this is a very big size radar, almost 6 meter by 4 meter. That's the size of the total radar. Next, I am moving to synthetic aperture radar. Synthetic aperture radar is having advantage of move. It will take the advantage of movement of the radar. So once its path swath it is there, once it is moving, it will take the advantage of that, and the entire data it will take of the swath and integrate it, and then they will post processing image will come out. There is a difference between this radar and this is the multi-object tracking radar. This is phased array, this one also phased array, but there is a basic difference is that will track means tracking radar will automatically instantly give the output, but imaging radar will not give instantly. It has to process and give the output. It will take some time, not instantly. This is the basic difference. Now there is these are the very big subjects. There was a synthetic aperture radar which went with Chandrayaan 2. You might have heard Chandrayaan 2 and 3 that two things happened. Chandrayaan 3 landed properly and all of we celebrated along with our countrymen, but Chandrayaan 2 was not a success fully. It was a partially success because it has a orbiter which is still working in orbit. So Chandrayaan 3 orbiter we have not taken since Chandrayaan 2 orbiter was working, and but we have used the lander, and lander from there robot came out and it has roamed throughout the surface of the moon. So this part what ISRO did, Chandrayaan 2 orbiter was taken the image of Chandrayaan 3 landing site. You can see there before C1, C2, C3 are meter scale reference craters. So some craters they taken and characterized these are the locations, and after that when Chandrayaan 3 landed they have found the location properly. So these are high resolution polarimetric mode, different type of data they have taken, and with that they concluded that position is known to us properly. So characterization is one of the important part for any radar, so that we know where it is going to sit. Before that its characterization is done. Otherwise, precisely telling the location is very different. Next, this is another. I think this is the next. Our big mission is NISR, NASA ISRO Synthetic Aperture Radar. It's a big project. Already work is going on. Left hand side, this is the artist impression. I'm showing this one. Is one satellite will move in the sky with this much big size antenna. And the beauty of this antenna, you can see here right hand side, it is in some clean room where antenna is folded. And so when satellite you are seeing here, you can correlate, but antenna is not there. Antenna is like an umbrella. It is folded. After going there, it will open one by one segment. So that will be beauty, and it will throughout the world it will roam and take the image, and it will create a profile height, including synthetic with synthetic aperture and imaging. Both together it will make the profile throughout the world. What will be the advantage? So what we came to know for some of the zones, entire zone it can be done, and we can anybody can ask a question like that. Why for that this much synthetic aperture radar is required? It can be done with a camera. Yeah, that is correct. Very cool. If that type of question, if I get, I will be very much happy. But no questions till now. So it's like the advantage of the synthetic aperture radar is when microwave is working, day and night it can do the operations, whereas optical camera can work in daytime only. So that is the limitation of optics. Though high resolution optical cameras are there, but only daytime it can work and take the image and it can be processed. So that is the advantage of the NISR. Throughout the 24/7 it will operate and it will give us the profile. Next. Earlier also I mentioned some of the systems I will mention. So this is called CATF, Compact Antenna Test Facility. For to showing this, actually I have taken the picture. One satellite you can see here. This is the satellite is standing there, and one is you can see here one antenna, another antenna, something circular like is there. It's a convex concave combination. Compact antenna test facility. So antenna normally it will radiate long distance, then only we can characterize. But if anybody is telling me to make it small, so for that purpose, these type of arrangements are there. Well, I think nowadays lot of compact internet, especially throughout the country, it is there. What they will do, this concave and convex combination, like it's like a glass. EM theory is also almost is equal to light. So similar way here also convex and concave combination is there. With that, they will extend the range of this compact antenna test facility. So this is a good measurement method. I think some of you have experience on this, or some if you get a chance somewhere, don't miss it. You will you'll be learning lot of things from this area. There is microwave now. Question is this our how we can work for students. That is the question. Then we can tell that. Always no need to make any microwave device you have to make, not like that. You can make it's very good. Otherwise, you can work for characterization. Some big systems are there, they are having data outputs are there. People are not there to characterize the data, that whatever we are getting and what is present information, both are matching or not. That's the way to do the characterization. That also a big work, and I think it's one of the challenging work. Somebody has made something and another person is sitting and characterizing it. That may be great work. So that is the another way to do good work and get self satisfaction. Next, assembly at clean room. Any, let's say this is actually JPL lab. We got this picture. You can see blue color. Some of the absorbers are there. So they may be testing somewhere. I have shown this to just to open that this is how satellites are kept inside a testing bay. All things that will be done, testing will be done after transporting to the launching center. So this is a way how they are keeping the satellite as well as doing the testing inside that. You can see some of the people's wearing white apron. So clean room, whatever the process are there, like that way they will follow all the things. So these are these much uh, very specific way and careful way they will handle the satellite. Next, yeah, C-band polarimetric Doppler weather radar. Presently, I am working in this area a long time. Almost this is actually how the Doppler weather radar products. In left hand side is from satellite image, right hand side is from radar. Left hand side is from space segment, and right hand side is from ground segment with the microwave source. So these are showing almost 1:1 time. You can see almost time is matching 6:30 and 6:29, just 1 minute plus minus. But the image is almost showing the same, and eye also formation we can see here in it's very clear in microwave area. Optically also we can see here. This is there on my eye formation. This was taken during Okhi cyclone in 2017. It hit Kerala and it was a devastation. But what this radar or micro satellite image has done, the disaster management team got the information quite prior before, and they have shifted some of the coastal people. So at least some of the lives we have saved. Some people who before earlier days this much information was not there, so it used to hit the coastal area first, and it is a devastation for those people. So life saving approach this one is. Next, there are different frequency bands as I mentioned earlier in DWR. S band is there, C band is there. Presently, X band also is coming. This is S band radar left hand side. It is most possibly it is in Gopalpur, Odisha. Sorry, near to Gopalpur beach. That famous people are going for tours. On the other side, if you see a building with this football type, is some structure is there. That's called radome. Technically, it is radome. So inside that, normally antenna is there, and it's a radio frequency transparent. And once it is radiating and getting, and so inside there will be no disturb, and it is a temperature control for the all RF instruments. This one is different structure. I have taken picture because of you can see this structure and this structure both are different. Anyway, that time they are installing, so it's a different way, and you can see very clearly some nut bolts are there in the junction. So this is also one of the very critical design. People are working in this so that RF micro frequency wave should not get interference because of the junctions with metallic bolts. That much level they are taking care. So these systems are. I'm initially also I told that it's a system wise I'll show. So it will show the system how it is working. Next is another is DWR. We are having Trivandrum, Shar, Kochi, and Gopalpur. These are the all linked with ISRO work, and so many are there. But those are not. Those are in IMD domain. So you can see here these are the support during the monsoon months. How the pictures are taken and slightly zoom. The picture will be very clear. You can see all are UTC. UTC means universal time they have taken, and at the same time you can see the different file size. Here you can see the elevation 2 degree. Normally it will go up to 20 degree with some circle. Then display range 50 kilometer. They have set up to 50 kilometer will take for this uh, measurement, and then scan elevation is 0, 5, 21 like that they have taken. PRF low and high 450 and 600. So 600, 450 hertz and 600 hertz, just to give a glimpse how it is working. Some of you may be in the radar zone, maybe see faculties, they may be knowing all this. Pulse width is 1 microsecond, clutter filter is off, then scan range 240 kilometer it can go, but they are showing here display is up to 50 kilometer, and preprocessors and filters. Any questions up to this?
Dear participants, if you have any queries, please ask.
Okay, I'll move to next. Next is some cloud radars. This one, you can see here the cloud radars. Earlier also I mentioned that one is movement of clouds and another is inside the cloud, how the density of the clouds and what type of clouds are there. Nowadays they are doing research because you might have heard that cloud burst is often happening in different area, and if you see very carefully, follow the news, it's like a general knowledge. Always, and it is washing out the total that valley. So these are the companies, few companies I have mentioned there, that they have this type of ready-made products. They have made, they have done actually experiment, and they have developed these things. Not it's not a single day, but the why I kept this one. This company is made okay very well. They are doing business very well. But why I am putting here? But you all will be surprised that university funded project. They made all the thing, they transferred the technology to these companies, and these companies are making and they are selling. They are just to multiplicator or technology seller to public. Now the university is doing the next level research and they are selling the previous version product in the market. So they have a university is having a very good strength of students as well as faculties. So many departments as a total. There is a collaboration program means it's a very powerful. So like that they have utilized their resources. I can tell that it's a optimization of resources they have used and they made the product. It's very promising. They have shown the way. One is working with technical thing and another is technical management. That these have they have shown the technical management how a university can make a product and it is a really sellable in the market. Next product of this cloud radar. You can see here there are different things. I will show few points very carefully. You can see here. You can see how the thing is happening. This is height and this is time. With respect to time, that place, height, how is the changing? So it's a like a time, it's running. Now 6 o'clock it has started and up to I think 6 o'clock and still more. How that area cloud has changed, and sometimes nearby 12 o'clock it became red color. Red color means you can see here more precipitation. It's the reflectivity they have mentioned. So more precipitation with time, how it has changed. Similarly, you can see height as well as ice cloud. So you read these blue things are ice related. Then some of the insects are available some of the time, that is shown in this green color because of high resolution radar. All these things are coming. Melting layer, inside that melting layer also mentioned. So this way they have done the analysis, and downpour also they have shown. You can see here heavy rain is there, red color. Heavy reflectivity rain is there, two places, this one and here also. This much it is coming down at a time. So these are the things they have analyzed and taken data and analyzed and shown that how important is cloud radar. And next, it will be the very one of the important uh, radar for IMD, Indian Meteorological Department, for predicting weather of India. They are trying to implement all these things. Already they are having some of the sensors. This will be maybe next upcoming sensor for them to predict next rain, how much it will be intensity and how long it will be there. That will come out with this sensor. So this part is over. Up to that, anybody has question, then I will move to next part. I hope no
Dear
questions.
participant, if you have any question, please ask. Sir, I guess there is no question. You can
Okay.
proceed, sir.
Okay, I will go move next. Next antenna testing facility. This is like I have shown earlier one clean room that how it can be done. This is normally I have seen so many universities they are keeping, not here, maybe in the foreign universities they have made the structure, and you can see antenna support structure. We are looking from the top to downside, and this some tooth sawtooth type is seen. It is absorbers. So antenna and in front side one bar is there, it is moving. It is the system. There is a test antenna red color. It will move like that and it will take the information throughout the time scanning. So next I am going to the picture, actual picture. You can see this bar, just it is moving towards us, and one, two, three white color sheets are there. These are the antenna, and red color throughout the thing you are seeing. It's a this absorbers are thing. This is near plane antenna measurement facility. Visualizing the antenna, as I mentioned that anything is antenna. In future maybe a lot of people will be working on this, I believe, and it will be improving the antenna skill, antenna engineer skill and efficiency. Next next this is the one of the beautiful place in Kolkata, Hooghly River, Howrah Bridge. But why the picture is this color? Normally we are not habituated to see on this color. Actually, normally whatever when we are going by flight and taking picture, it is different. And this is microwave imaging. So radar imaging satellite data. So this is a microwave imaging data. It can work for day and night, as I mentioned. Normal photo, whatever we are habituated, we can see that is different compared to this one, but this is one of the important for strategic purpose. Day night anytime they can switch on and get the information. You can see here, even if next to Howrah Bridge JT is also visible, they have identified, but their identification is different compared to us. This processing is entirely different, not like optical processing, but at the same time this can give a very important data for the time being, even if at midnight also. Next is TR unit or LRU. why I kept this one. This is like a phased array antenna. There is a 1 TR module unit and it will be kept like that. So it's like a cell, 1 cell in that with one connected with 1 antenna element. So like that way, phased array, this is one of the important part which is happening nowadays. Is very important to make a TR module. And why I kept LRU, line removing unit. It's like that once gone bad, you can take it out and push it. So these LRU TR units are very important nowadays. For different frequencies, it is used. The size will depend on frequency. At the same time, why I kept, because nowadays I am seeing not only in outside countries, in India also so many universities are working on TR unit, a unit or TR module, whatever different names they are telling, and they are making also. So that is a very great achievement, I will tell. If anybody is interested, you can work in this area. There is a transmit and receive both paths together, and you can make it, and it will be a very great achievement. And it's not very critical also making a TR unit, but you should have a good uh, planning on design so that it should be a compact one. Next, this is a National Atmospheric Research Laboratory. Some of you might have visited Tirupati Temple. It's very close to that place called Gadanki. Earlier, I used to go very often there for my work. There was an antenna establishment. So they are having lot of sensors for weather monitoring. They are doing entirely weather research. So different type of what's going on, and they are doing very good work. And all these different lot of sensors, and combining all the data, they are giving good output information regarding weathers. Next is Weather and Climate Research Group. This is a one group why we have taken this page. They are showing different relative humidity with respect to height and some other parameters which are showing very live. They can, if you can go there immediately, they can show this is the present situation. Morning onwards, these are the variation. Like that way, live system they made. It's amazing. They are working. Next is Charles DWR data. Yeah, is why we have shown earlier and here. There is a difference between that. You can see here one Mosdaq. Mosdaq is a website where all these data informations are there. Optical satellite information is there. You can get all the information free, and Space Application Center is the admin. If anybody wants and interested, they can make a login and get the information, and with that data you can do the analysis and research throughout the time of throughout the year. Data is stored there and you can get it on request and carry out this one. That's why I'm showing Mosdaq, because Mosdaq is a website where all the information will be stored. Next, this is one of the present scenario. You can see that space situational awareness. Space, what's happening there, situation, awareness means if we know all the points. You can see bottom there is written Chandrayaan 3 launch delayed by 4 seconds to avoid collisions with debris, reveals ISRO report. I am not going inside the report, but this was the thing when our launch was postponed for few seconds at the last moment, because we came to know some objects will be there in our planned launching path. Launching path means where trajectory will be there. So it was postponed by the time so that it can pass and the rocket can go and satellite can safely move to the forward. So this is one of the important thing, and a very important matter is going to happen because it's linked with the strategic area. So this is, though it's a in India military domain and civil domain is very clearly defined, but some of the places it is very overlapping zone. This is one of them. Yeah, here is a rocket launching I have taken got from my one of my friend. I'll see if I can play this one or not. Yeah, you can see that some clouds are there. Why I have taken this one? Because I have seen that like this one, you can see how what it happens actually. We have to take a precaution for this during the tracking via a radar. But when rocket is going, what's happening for that purpose? Only I kept. I have taken it from social media. One of my friend recorded Sriharikota and he shared. I got it, and it was in at that time it was very popular. Just I'm playing for a few seconds. You can see the rocket is going high from here. And people are enjoying backside. Yeah, now you can see it's going inside the cloud. What's going to happen? Yeah, now you see how the color is changing. It's going initially, rocket is going initially fast straight. Then after going some height, it will change its attitude, means it will take a right turn and it will go. It's very common we used to see in TV. Anyway, I'm stopping this one here itself. Thanks to all of you for your patience. This summer I was working in hot sun. It was very hot at the time, more than 40 degrees. And you can see already his skin became uh, brown and all these things. And big side also something is seeing. There we were projecting our antenna to get signal. We are struggling literally at that time. So thanks to all of you for your patience. I'm with this. I'm concluding. Any question is there, you can ask, or any different apart from this related also questions also you can ask.
Dear participants, if you have any question, please ask.
Hello.
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 Yes.
Am I
Yes,
audible?
I'm listening.
Sir, what is radar cross section?
Yeah, radar cross section is energy whatever we are pumping and we are getting back. So sometimes it is linked with target, how much the target size it will come back. Sometimes it will be attenuation also will play into picture in between. So radar cross section normally it is valid for the target whichever we are taking. Sphere if it is a ideal, otherwise flat surface also people are taking. Some of people are working in radar cross section characterization. I know very well. Even if they are rotating also, not in a static plane, dynamic plane also they are doing. And I think some of the IITs they are having very good structure. They are doing all these things, but it is not a very critical to all the things are happening in big institutes. Small institutes also people are working and they are getting very good results and they are publishing also. So I can any specific question on this you can still ask me that anything R&D related establishment formation or something else. Otherwise,
Sir, 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 what is pulse repetition frequency in radar system?
yeah, this is very good question. Pulse. There are two types of radar. Earlier days, one is continuous wave radar and one is pulse radar. Continuous wave means it will be continuously. Radar is basically three main systems. Okay, one is transmitter, receiver, and antenna. In between, antenna will be there. So transmitter two, if you are radiating the energy, antenna, so that will be continuous. You can send. Another will be another antenna and continuously receive. This is one way. It's called uh, bistatic. Another is monostatic. One antenna common for transmitter and receiver. So when transmitter is transmitting, receiver will not get any signal. But when receiver is getting signal, transmitter will not transmit. So in between, they will put a circulator. So circulator is a must for a pulsed radar, whereas for a FMCW radar it is not required because people will normally put two transmitters, two antennas, one for transmitter, another for receiver.
Thank you, sir.
Okay. So with this, I want to conclude. Already 3:27. I already promised by 3:30. This session will be over. If any more one more question I can take, and we can conclude this session.
Dear participants, if you have any more questions, please ask, sir.
I think it's a very good experience for me. I will request to take a screenshot of this. How many people are present there? I think in my PC it is recursive. I am not able to see the all faces clearly here. So I request the somebody can take a screenshot of this all the people and take and provide me. It will be very nice. Or otherwise, snipping tool I can take.
Okay, sir, we will.
1 minute, I will just take. So we'll conclude this session. So further also, if you have any question later, you can contact me. I will definitely try to answer your questions. So all the best to all of the participants, and hopefully it will be a good session for you and useful for you. Then only all this thing will be there will be meaning. Best wishes to all of you. Thanks to the organizers. Okay, bye. See you.
Thank you, sir.
Thank you,
All the
sir.
best.
Yes, we are extremely fortunate, sir, to have you with us today. And your passion for the topic, modern radar technologies and application, was evident, sir, in every word you spoke. And it has led to
All
the
the best for your
conclusion
future.
of this remarkable. Okay, as we approach to the conclusion of this remarkable journey at SUSET 2024, it is time to express our heartfelt gratitude to all of those who have made this event a resounding success. I would like to request our HOD sir, Professor Dr. Showman Paul, who has been a pillar of support and guidance throughout the planning and execution of SUSET 2024. His leadership and dedication have been instrumental in ensuring the seamless flow of this FDP program. Sir, now I would like to request you to formally deliver a vote of thanks to our renowned speaker and our participants.
Good afternoon. Ahuna, am I audible?
Yes,
Yes,
sir.
sir, you are audible.
Okay. So, good afternoon, everyone. It has been such an honor to be a part of this wonderful event. On behalf of the Department of Information Technology, Haldia Institute of Technology, I would like to extend my heartfelt gratitude to our esteemed guest, Professor Subroto Mondal, Principal of Haldia Institute of Technology. While addressing the inaugural, he said the workshop on FDP will discuss issues relating to artificial intelligence, deep learning, Industry 5.0, and sensor and radar technology, with particular emphasis on the emerging research paradigms in the emerging area of computer science concerning its application in various fields. My sincere thanks to our Registrar of HIT, Dr. Anjan Mishra. Sir, we appreciate your keen interest and the key role you play with the encouragement of faculty development program. We look forward to your strong support in future also. I would like to express my gratitude to all our respected deans, Professor Tarun Kanti Jana, Professor Ashit Barun Maiti, Professor Radha Das, Professor Rajiv Kumar Dubey. Thank you, sir, for your presence and support and guidance that inspires us to organize such activities in association with IQAC. I extend my appreciation to all the members of organizing committee for their unwavering support and handling the event throughout the 5 days of FDP. I also extend my heartfelt gratitude to the faculties from our college and outside the college for their patience, presence, and active participations throughout the FDP. Thank you for your keen interest and positive attitude towards sustainable technology during our event. Your time and contributions were invaluable to us. Now, I would like to extend my gratitude to Professor Amitabh Das, the Research Associate Professor of South Carolina University. On the first day, Dr. Amitabh Das shared his expertise over implications of AI hallucinations and adversarial attack in AI. AI hallucinations is a phenomenon wherein large language model, that is LLM, often a generative AI chatbot or computer vision tool that perceives patterns or objects that are non-existent or imperceptible to human observers, creating outputs that are nonsensical or altogether inaccurate. AI models can also be vulnerable to adversarial attack, wherein bad actors manipulate the output of an AI model by subtly tweaking the input data. This can become a significant security concern, especially in sensitive areas like cybersecurity and autonomous vehicle technologies. AI researchers are constantly developing guardrails to protect AI tools against adversarial attacks. My sincere thanks and gratitude to Professor Josna Kumar Mondol, the distinguished professor of Kalyani University, for sharing his thoughts and expertise over neural cryptography. On the second day, Professor Josna Kumar Mondol was a highly informative and impactful session on neural cryptography. Neural cryptography is a branch of cryptography dedicated to analyzing the application of stochastic algorithms, especially artificial neural network algorithms, for use in encryption and cryptanalysis. Cryptanalysis is the study of analyzing information systems in order to study the hidden aspect of the system. Cryptanalysis is used to breach cryptographic security systems and gain access to the contents of encrypted message, even if the cryptographic key is unknown. Professor Mondol exclusively narrated about all the aspects of neural cryptography, which is highly beneficial for current research worker in this particular domain. Now I would like to convey my gratitude and thanks to Dr. Joydeep Sengupta, the Assistant Professor of VNIT, for his illustrative speech over wireless sensor network. The third session of the Faculty Development Program, featured by Dr. Joydeep Sengupta, centered on different challenges of wireless sensor network, such as limited power energy, limited processing, and storage capabilities. Beside that, there are some other issues such as heterogeneity, security, scalability, interference, and reliability. He also elaborately discussed about the advantage of wireless sensor network, such as low cost, wireless communication, energy efficiency, scalability, and real-time monitoring. Nevertheless, wireless sensor network are valuable systems that enable efficient monitoring and data collection across various applications. They play a crucial role in industries like environmental monitoring, healthcare, and agriculture by providing real-time data insights. Despite challenges such as energy efficiency and security, wireless sensor networks continue to evolve with advancements in technology, promising even more effective and reliable performance in future. I sincerely appreciate and extend my thanks to Dr. Nallakaruppan Kailasnathan, the Associate Professor of Sri Balaji University, Pune, Dr. N. Kailasnathan enlightened his thoughts and valuable ideas about the transition of Industry 4.0 to Industry 5.0, application of AI and IoT in Industry 5.0, and IoT security. Industry 4.0, also known as the fourth industrial revolution, has already had varieties of industries, has already had enormous impact on the global economy and the way business operate in a variety of industries. The technology has helped to make the companies the technology has helped to make the companies more agile, efficient, and even environmentally friendly. One of the biggest features of Industry 4.0 is the use of connected technology, which allows business to exchange real-time data, optimize process, reduce cost, and improve quality. Industry 5.0, the next big step, is still in development. It is expected to focus on collaboration between humans and machines to empower people to fully utilize their skills and make work safer, more efficient, more meaningful, etc. Industry 5.0 will also mean the introduction of even more advanced technology such as artificial intelligence, IoT, and robotics, which can support and complement humans in new ways. Overall, it can be said that Industry 5.0 holds an exciting future for business, and it is worth keeping a close eye on its development. IoT security is the technology segment focused on safeguarding connected devices and networks in IoT. IoT involves adding internet connectivity to a system, interrelated computing devices, mechanical and digital machines, objects, animals, and people. Each thing has a unique identifier and the ability to automatically transfer data over a network. However, enabling devices to connect to the internet opens them to serious vulnerabilities if they are not properly protected. Finally, I would like to take this opportunity to thank Dr. Shubhomoy Basu, Distinguished Scientist of ISRO, for his enlightening and impactful speech over modern radar technology and its application. Radar is an electromagnetic sensor used to notice, track, locate, and identify different objects which are at certain distance. The working of radar is it transmits electromagnetic energy in the direction of targets to observe the echoes and returns from them. Here the targets are nothing but ships, aircraft, astronomical bodies, automotive vehicles, spacecraft, rain, birds, insect, etc. Instead of noticing the target's location and velocity, it is also obtains their shape and size in sometimes. Dr. Basu elaborately discussed about different types of radars for space applications, existing cloud radar systems, cloud radar profiles, antenna testing facility, and that to be highly encouraging and beneficial for the faculty members who are working in this area. On this note, I would like to conclude my speech and extend special thanks to our Honorable Principal, Registrar, all the Deans, all the speakers, members of organizing committee, and all our participants for making this event a memorable and grand success at the end. I would also like to thank each and every one of you for being here and making this event a wonderful and memorable one for the entire communities of teachers. Thank you once again.
Thank you so much, sir. As we conclude SUSET 2024, let's reflect on the knowledge we have gained, the connections we have made, and the inspirations we have found. We have been privileged to witness an extraordinary exchange of knowledges, ideas, and innovations. Our speakers have shared their expertise, our participants have engaged with enthusiasm, and together we have fostered a vibrant community of learning and collaborations. I encourage each of you to take the insights and experiences from these sessions and apply them in your work, continuing the spirit of innovations and excellence. Thank you to all my participants. Now, I would like to request all my participants that the assessment and the feedback link has been provided shortly. All of you to please join positively within 8 p.m. Please fill up the link within 8 p.m. Otherwise, the link may be deactivated. Thank you so much.